Good morning, dear students. So, in last lecture, we have completed a very important theory that was photoelectric effect. Now, in today's lecture, we will continue numericals of method number 2. I think you all remember this important point that we have studied method number 2, and here the important formulas of method number 2. The first one, E is equal to H nu. The second one, E is equal to Hc upon lambda. Now third one, it's very important. Just see, if we want to calculate energy in mole, then we will use this formula. E is equal to Nh nu, and the fourth one, E is equal to Nhc by lambda. Very special instruction that if we want to calculate energy in mole unit, then we will use these formulas. So this is very important point. If we want to calculate energy in mole unit, then we will use this formula. Here N is equal to एवोगैड्रो नंबर. स्टूडेंट्स ये कि एवोगैड्रो जो नंबर है ना, वो नंबर अभी फिक्स फिगर है इसका, आप सबको शायद मालूम होगा. 6.022 into 10⁻23. मैं बेसिक कॉन्सेप्ट वाला चैप्टर जब पढ़ाने वाला हूँ ना, तब मैं ये फिगर कैसे आ रहा है वो प्रूफ करके भी आप सबको दिखा दूंगा. 6.022 into 10⁻23 किस तरीके से आता है. So n is equal to Avogadro number, and the number is 6.022 into 10⁻23. But right now you all have to remember this formula. Okay. Now we will go in a numerical of textbook, and the numerical number is problem number 2.6. Problem 2.6 is here. Okay, so the question is, calculate energy of 1 mole photon. So the question is here, 1 mole photon, and its frequency is given 5 into 10⁻14 hertz, and we have to calculate the energy of 1 mole photon. Just see, the mole word is here, and if we want to calculate energy in mole, we will use formula number 3 or formula number 4. But from 3 or 4, which formula is applicable for here? So just see, if frequency is given, then we will use formula number 3, and if wavelength is given, then we will use formula number 4. So in this example, frequency is given, then we will use formula number 3, not number 1, because number 4, 3, 4 are mole calculation, and we have to calculate it in a mole unit. So we are using formula number 3 here. E is equal to Nh nu. Again I repeat a table, that if we want to calculate energy in joule, we will use Planck constant, joule into second, wavelength in meter, and celerite of light, meter per second. Okay, so we will use the formula E is equal to Nh nu. Here N 6.022 into 10⁻23, Planck constant 6.626 into 10⁻⁻34. If we are using Planck constant in joule, then our answer, joule into second, then our answer of energy is in joule, and the frequency in hertz, 5 into 10⁻14 hertz. Okay, here the final answer, 23 plus 14, that means 37. 37 minus 34 So 10 raised to 3. Now the multiplication of this 6.022 into 6.626 into 5. So 199.5 Joule. Here it is the answer of Joule. If we are using 1.995, so 2 decimal point, we are going 2 decimal point on the left hand side, so 2 power increase. So 1.995 into 10 raised to 5 Joule is the answer of problem number 2.6. So is it clear? This is problem number 2.6. So you all have to remember this important point, that if we want to calculate energy in Joule per mole, then we are using this formula. This is problem 2.6. Okay. The next one, practice session. Okay, second one, calculate energy in mole for 5000 angstrom wavelength. Just see, in second numerical, wavelength is here 5000 angstrom, and we have to calculate energy. So calculate energy in mole for 5000 angstrom wavelength. Okay, so lambda is here, it is 5000 angstrom. So first of all, we will convert this angstrom into meter. So it is 5000 into 10 raised to minus 10 meter. So 5000, 5 into 10 raised to 3 into 10 raised to minus 10. So 5 into 10 raised to minus 7 meter is wavelength. 5 into 10 raised to minus 7 meter is wavelength. Okay, we have to calculate energy. Wavelength is given, that's why we are using formula number 4. E is equal to NHC by lambda. E is equal to NHC by lambda. Here N 6.022 into 10 raised to 23. Planck constant 6.626. 10 raised to minus 34. Cellulite of light 3 into 10 raised to 8. And this is 5 into 10 raised to minus 7. Lambda is here. Okay, now the final conclusion. This is the general mathematics, and we know that if we want to calculate energy in joule, then we are using Planck constant, joule into second. We are using cellulite of light meter per second. We are using wavelength in meter. Okay, so 6.022 10 raised to 23. So this 10 raised to minus 7 will go into upper side. 8 plus 7 minus 7 है ये वो ऊपर जा रहा है तो ये plus 7 हो जाएगा. तो 8 plus 7 that means 15. 23 plus 15 that means 38. 38 minus 34 it is 4. Now the answer of 6.022, take a calculator. 6.626 into 6.022 6.626 into 3 divided by 5. Answer is 23.94. So if it is 2.394, then we are using 10 raised to 5. This energy is in a joule and joule per mole. So this is our final answer. 2.394 into 10 raised to 5 joule per mole. So if we want to calculate energy in mole unit, we are using N, with N is Avogadro number, and Y 6.022 into 10 raised to 23 figure is here, and we will understand, or we will explain this in our next lecture. But I will give you now further practice. I will give you now further practice of this type of numericals. Okay, so just see which are the numericals we will solve. The first one, this now we will start our practice session. Practice session. So the first one of today's practice session is here, that calculate energy in mole 4000 angstrom wavelength. The second one, calculate energy in mole. 4580 angstrom. Calculate energy in mole for 2000 angstrom. Now calculate energy in mole for 5.8 into 10 raised to 15 hertz. Calculate energy in mole for 6 into 10 raised to 14 hertz. Calculate energy in mole and frequency for 3500 angstrom wavelength. And the seventh one, calculate energy for 400 nanometer wavelength. So these are the important practice session for today's lecture. So all the students, you must have to do these two important formulas. E is equal to h nu and E is equal to hc upon lambda. If we want to calculate energy in mole, then we will multiply it with Avogadro number. But if we want to calculate energy in a simple either joule or all, then we will use this formula. Simple, E is equal to h nu or E is equal to hc by lambda. So this is our important practice session for today's lecture. Okay, so that's all from today's lecture, that we are doing our best for today's lecture. So ये आप सबको अच्छी तरीके से सोल्व कर लेना है. ये सभी न्यूमेरिकल की इमेज में आप सबको भेज रहा हूँ, अच्छी तरीके से प्रिपेयर कर लीजिएगा. ठीक है. सो थैंक यू ऑल फॉर टुडेस लेक्चर.